Yes.
Good morning, all the students. How are you? I hope you all are best and fine. Now we are going to discuss yesterday's continuation concepts of our vectors and as well as the scalar compounds, whatever there. Yeah, yesterday we already completed about that whatever other components of 9 different types of vectors we are considered up to the null vector they are completed. Now we are going to discuss the remaining concept. Yeah. Now we are going to discuss about the concepts, whatever the orthogonal vector and as well as the axial vector and as well as the proper vector, all the components now we are going to discuss here. Yes, one second. There is we already completed null vector. Now there is a what is the properties of zeros vector? Properties of zeros vector. Properties of zeros vector. Yeah, what is the properties of zeros vector here? Yes, and here first property we are taken as a plus 0 bar is equal to taken as a bar. Okay, clear or not of this? Second property we are taken it is as a plus b bar plus 0 bar null vector is equal to taken as a bar plus b bar. Third one, okay, whatever third one it is there, a bar minus b bar, okay, now a bar minus a bar, it is equal to what? 0 bar. Got it? And the fourth one, yes, n into 0 bar is equal to taken as the 0 bar. Got it or not? These are only called what? Null vector properties. When you take one vector, it is add with the yes null vector. It is as what actually again the same vector will be given. Yes, either maybe you take a more than one vectors are added with that vector. It is not influenced that the subtractions and as well as the that whatever the addition is there, the addition is not influenced by the null vector of a original vector. Got it or not? This is the one thing. And next component, what we are considering, there it is when you are multiplied with this one integer. Okay, clear or not? Whatever the integer thing is there, the integer thing is not affected the magnitude of the vector, null vector. And as when there is a two opposite vectors are taken as a summation of the two opposite vectors are become what actually? Yes, that is a become null vector. Summation of the two vectors are become null vector. All the students, please note down this all the properties, whatever there. Okay, and now next component is axial vector or one-dimensional vector. Which one is called axial vector? Which are contained along the axes. Okay, now yes, there is a we have the three axes. Just started at here origin and moving along either x-axis or a y-axis or a z-axis. Along the axis, the vectors are there. That vectors are called what? Axial vectors. The vectors are called what? Axial vectors. I hope you understood now. Next component, what we are takes, there is one more thing it is there that is only called as two-dimensional vector, 2D vector. Which is called 2D vector? Which are belonging to the two planes. Okay, now there are two axes. One plane here, XY plane it is there, na? That is called the what? The 2D vector. The space vector is totally different from these vectors. Okay, the space vector is nothing but it is a contained in a plane. Okay, na? But here this is also one of the component that is also called a plane vectors. Okay, na? When you are taking a plane vectors, either they belongs to xy plane, or they belongs to x dash y plane, or they belongs to the x dash y plane. Okay, na? Y dash plane. Okay, like that vectors are called what? 2D vectors. Okay, got it or not? The vector which is belongs to the, yes, which one it is? Belongs to the plane, not along the axis. Okay, that is called 2D vector. Next one is 3D vector, which is called a 3D vector, which is called 3D vector, which is called a 3D vector. The vector which is belongs to the three axes. Okay, here we consider the three axes, not the two axes. Three axes when we consider, that become what? That is a become as, okay, na 3D vector. Which one? You know very well. There is actually the coordinate axes of three, x, y, and as well as the z. Suppose you take our room. Our room is one of the three-dimensional thing. In this three-dimensional thing, we want to find out our position. Okay, now by using the 3D vector only, it is a possible. Simply, when you take here I bar only, or 3 I bar, it is a bar, it is a belongs to x-axis only. Okay, clear or not? Suppose you take only 3 j bar. J bar is a, yes, unit vector along the y-axis. Suppose you take a 3 k bar only. The k bar is what? The k bar is here, yes, the unit vector along the z-axis. Got it? Or? Yes, I hope you got it here. 3 I bar, 3 j bar, 3 k bar. How we consider these three things? There is a what? It is a x vector along the z-axis, vector along the y-axis, vector along the x-axis. Suppose 2D vector, it contains compulsory two components. One is along the y-axis, another one is along the z-axis. One is along the x-axis. 3i plus 4j. This is called the what? Along x-axis. Okay, clear or not? There is a two components should be. It is along the x-axis, it is along the y-axis. Got it or not? In this way, there is we consider the different vectors along the different directions. Okay, na? Yes, under a different plane. Suppose you take a 3D vector, it is a contain three components. 3i plus 4j 5k. Means what? A xi plus a yj plus a zk. Meaning what it is? It is a z component, it is a y component, it is a x component. X axis component, y axis component, z axis component. The three things are there, that is called three-dimensional vector. In case it is the two components are there along one is the y-axis, another one is along x-axis, it is a called 2D vector. Or otherwise it is a content only along x-axis or along y-axis, it is a called axial vectors. Got it? This is all about the three vectors here. Got it? Yeah, please note down. Yeah, next, all the students, next component, it is angle between two vectors. Yes, how to find out there is a angle between two vectors, and when there is an angle is a formed, that is also important here. Yes, the vectors, the two vectors form a point. Yes, are drawn such their arrows head should be away from that point. Okay, clear or not? Yes, when there is a two vectors are meet, at that times there is an angles are formed. Okay, clear or not? When there is a vectors are, okay, suppose they are in this particular way, they are one is a parallel with the another. Got it? Or these are the parallel with one another. Okay, at this particular situation, there is a one is a parallel with another one. Okay, I hope you got it clear. Next, when there is a vectors are like this, they are called anti-parallel, but they not meet at one with the another one. When they are meet with the one another, okay, either in this format means what? Whatever end points are, whatever starting points are, one is a starting point, another one is an end point. Okay, clear or not? When they are meet with one another, they contain somewhat what angle. How to find out the angle? When the two end points are there, we get an inner angle. Okay, clear or not? This is called the inner angle. Otherwise, it will be get outer angle. Okay, clear or not? It will be totally take as a 180 degrees. Okay, you made a minus from it. Okay, clear or not? By angle loss, we are conclude about these things. I hope you got it. Angle between the two vectors are finding by their meeting positions. When there is a yes a head and as well as coincide with the tail, we'll get the what actually we'll get that if two heads are two yes tails are coincide, we'll get the what inner angles only. Otherwise, there is a, we'll get the what outer angle. Oh, get it or not, all the students? Yeah, there is a what? There is a two tails, or otherwise there is a two. Yes, we are consider it is a what? Two. Okay, like this. There is a two R, one is a coincide with another one. The angle may get inner angle, or otherwise one head is a coincide with the tail. There is a get as outer angles. Got it? This is the given here. Yes, and we are going to discuss about in exercises about these concepts. Yes, and as well as next there is the angle between the vectors is like that we are considering. Okay, clear or not? I hope you got it here. This is called theta. Okay, now angles we are considered in this way. Yes, angle between two vectors. Angle between two vectors. Got it or not? I hope you got it here. Yeah, next afterwards we have one more thing, that is only what only that is the next one is Cartesian coordinates. Very important it is Cartesian coordinates. Which one is called the Cartesian coordinates? That is what is the main using of it. Okay, Cartesian coordinate. Yeah. Which one is called the Cartesian coordinate? Here we are takes what actually there is we are takes the x-axis, y-axis, and as well as the z-axis. There is the three axes are there here. Okay, clear or not? Suppose we have to find out a one particle position with respect to all axes. Example is Suppose you are in your classroom. Okay, clear or not, all the students? Suppose you are at where? In your classroom. Okay, in a classroom, where you are? Okay, what is your position? How to find out your position? Okay, now, yeah, how do we find out our position? Yeah, our classroom door is as a one of the origin point. This is the door of your classroom. Suppose you are here. Yes, your benches are like that here. Suppose this is the board. Suppose. Okay, clear? And your board it is a contain one point. What is that? X comma y comma z. One of the component is there. You know very well. Yes, from the x-axis. What it is actually? From the x-axis, how far distance you are, and from y-axis, how far distance you are, and from z-axis, how far distance you are. Yes, like that. Whenever we give the explanation, that point is only called Cartesian coordinates. I hope you got it. Cartesian coordinates are nothing but we want to provide a position for a one particular particle with respect to y-axis, with respect to z-axis, with respect to x-axis. Suppose when we consider three-dimensional, we'll get the 3 points. Suppose when you consider two-dimensional, we get only the 2 points only. Got it or not? Yes, x comma y. When you draw the graphs, it's the time you have taken x-axis position based on one value and y-axis based on one more value you are considering. But extra to that, we are taken in our physics, there is a three-dimensional body. Suppose a globe, okay, or suppose a sphere or a cone. These are three-dimensional things. At that time, there is we are consider the position of that all the bodies, whatever contain on that. Yes, with respect to x-axis, with respect to y-axis, with respect to z-axis, that will be taken at one particular point. That point is only called Cartesian coordinate. In case it is the x-axis based, that is x coordinate. Yes, we are taken like this: x1, y1, and as well as the z1. There is a what? It is a one point. Okay, when we are taken together, it become all Cartesian coordinate for a three dimension. For a one dimensional, we are taken x1 comma y1. That is what? What is the position of the particle with respect to x-axis, with respect to y-axis, with respect to the z-axis. These are only about whatever our Cartesian coordinates and as well as the angle between two vectors. Okay, now suppose one second, your position and your friend is somewhere here or here. These three members are contain same Cartesian coordinates. No, their position is different from this position. This position is different from this position. Got it or not? May they are in a one row because of that y component is the same, but x component is a valid or not? Z component is a valid or not? Okay, clear or not? Yes, yes. Why I am write the z axis like that? No, z axis is towards the board. It is enter into the board and emit from the board. That is not possible to write here, na? Yes, there is a like this. These all our axes are like this. Okay, now the three axes are looks like this. Got it or not? Yes, this is the what? One second, it is towards you. This is the y-axis, this is the z-axis, this is the x-axis. Okay, in this manner it will be there. Got it or not? Yes, one second. Okay, when we rotate it, you'll get that. Okay, got it? Yes, this is only the components. Yes, we are taken. It is the x, y, and another z. That is towards you. Means what? It will be towards the board, na? Yeah. Like that, we are consider the axes, different axes, and that axis based what is the position of the particle that will be provided for us Cartesian coordinates. Got it? Please concentrate on this thing. The last one more vector it is also there, that is the orthogonal vector. Yes. Next component is the orthogonal vector. Yeah. Orthogonal vector. Yeah, which one is called orthogonal vectors? The vectors, whatever the vectors are there, whatever the vectors are there, the vectors are which are perpendicular to the another vector. Okay, clear or not? Orthogonal vectors are nothing but what? One vector is a perpendicular to the another vector. It is called orthogonal vector, 90 degrees, which is made as 90 degrees with the another vector. Suppose it is x-axis based on one vector we are considered. It will be what along somewhat y-axis, as or along the z-axis. Okay, these two vectors are become what? Orthogonal vectors. Suppose when you are take as there is a x I bar is one of the vector. Orthogonal vectors for it will become what? Y j bar and the z k bar are become what? Orthogonal vectors. Why? Because already we are discussed x comma y comma z axes are one is exactly perpendicular to the others. Okay, now that's why the vectors along the x-axis or y-axis or z-axis, it is called what? Orthogonal vectors. Understood not all of you? Yes, which vectors are contain 90 degrees angle between them, they called what? Orthogonal vector. When we are taken a 180 degrees and the direction is opposite to one another, they called what? Opposite vector. Okay, clear or not? When they are not contain any angle, they are become what? In case magnitude is same, equal vector. Okay, like that, angle based or direction based also we are define our vectors. Got it? These about our yes synapses about our yes whatever vectors are there. Okay, clear or not all the students? There is a different types of vectors, lot of types of vectors we are considered. Okay, and how to find out a Cartesian coordinates and how to find out the angle between them. Okay, these all are we are considered. Got it or not? This is only about our totally the components of vectors, different types, and as well as the components. Okay, angle, Cartesian coordinates, and it is a belongings to which type vector. That is a very important components. Okay, now yes, once read this all the vectors. Okay, now and as well as recognize it is a which type of vector. Yeah, now we are going with the what conceptual working worksheets. Okay, now before going to the conceptual worksheet, already yesterday we have discussed how to find out the mod value that is only given here. An example is there. Okay, now yes, below the 17 component orthogonal vectors, we have the what one example is there. Please look at that example. Yeah, what is that example? A vector 4 units along positive x-axis. 4 units along positive x-axis. Yes. Then what becomes now? The 4 units along the positive x-axis means what is that? Yes, in case it will become actually suppose the vector magnitude along the yes negative x-axis automatically become what? Yes, 5 units, but along negative x-axis, what it becomes now? Automatically minus 5 I bar. Got it? Or I cap. This I cap is a become what actually? The I cap is a become as a unit vector along the axis, the concerned x-axis. Got it? Or I hope you got it here. The unit vector along the x-axis. This is only we are interested. Yes, I hope you got it here. Next, after this, we have one more example they given. A bar is equal to taken as 4i minus 3j. 4i bar minus 3j bar. This is the one of the vector they given. What is the modulus of this A bar? Okay, now clear or not? Modulus, how we find out? Already I am given. Suppose one vector A bar is written as A1i plus B2j or A2j. Okay, the modulus is the become what? The modulus is under root of A1 square plus A2 square. Okay, clear or not? What it become now? Then A bar modulus is equal to taken as 4 square plus minus of 3 whole square. Got it? Under root of 16 minus 3 whole square become plus 9. Minus into minus plus. That's why it is become under root 25. Automatically that is a become 5. Okay now. Mod plus A bar is equal to 5. Yes. Yeah. This is only finding the modulus and as well as the when they given okay magnitude and as well as the axis how to write the vector. Okay, clear? Yes, these are the about our examples they given. Yeah, please note down. Yeah. Next one is conceptual worksheet or practice sheet based. The first question answer. Yes, if head coincide with a tail, then what the angle is between the two vectors? Head is the coincide with the tail, then outer angle make it. Okay, the answer is suppose it is a one vector. This head is a coincide with the tail of another vector. What the type of angle may get? Outer angle. The answer is a become outer. The answer is a outer angle. The next second question. Position vector is a vector that defines vectors. Okay, now clear or not, all the students? Position vector is one of the vector. Yes, that is defines. Sorry. Second question in the conceptual practice sheet. All those vectors whose initials are same, such vectors are called what? Okay, now such vectors are called co-initial vectors or co-current vectors. Okay, what they given? All those vectors whose initial points are same. Means what? Like these vectors are called what? Yes, co-initial vectors. They become what? Co-initial vectors or co-current vectors. Co-initial vectors. Yeah. Next, third question. A vector whose magnitude is if the two vectors have same magnitude and direction, they are said to be called what? Yes, the direction and as well as the magnitude. Both are same here. That vectors are called what? Equal vectors. That vectors are called what? Equal vectors. Okay, it is also 4 centimeters, somewhat of 4 centimeter, and they are towards the east, automatically it become what? Equal vectors. Yeah. Next component after this. If two vectors have same magnitude and parallel with each other, okay, clear or not all this? If the two vectors have same magnitude and are parallel to each other, then they are said to be. Okay, clear or not all the students? What happened here? The two vectors are whatever there, it is the same magnitude, but directions are also same. Co-current vector, already we have discussed it. The co-current vectors are nothing but they started from a same point. Okay, now that's why they called what a co-current or a co-initial vector. Yes, I hope you got it here. Yes, that is a concurrent vector and as well as the yes co-initial vector. When the vectors start from the same point, yes, whatever may be the direction, but they start from the same point, that vector is called co-current vector. Co-current vector. Got it? Or? Yeah, I hope you got it. Next, fifth one. If any vector possesses components along, define a unit vectors and null vectors. Fifth point, fifth question answer. Define a both. Yes, what they given? Define null vector and as well as the unit vector. Suppose A bar is one of the vector. Okay, the unit vector of the A bar is taken as a cap. That will be taken as a what? Unit vector of this. A bar by mod A is only called the unit vector of A cap. Already we are discussing. Okay, which magnitude, which vector magnitude is become unit. Okay, clear or not all the students? Which vector magnitude is become unit, that vector is called unit vector. That vector is called as unit vector. Okay, and as well as null vectors are nothing but the sum of opposite vectors. Sum of opposite vectors. This is a null vector. Adding of these two vectors are called what? Null vectors. Means what? It is A bar. This is a B bar. A bar is a minus B bar is equal to minus B bar. Then A bar, okay, of minus, when we are taken as the resultant of these two vectors is become null vector. This is a what? Unit vector. This fifth question is taken as unit vectors. Got it? Yes, these are the conceptual answers. All the students, please note down. The first vector is the outer angle. Second vector is the coinitial vector. Third one is the equal vector. Fourth one is the concurrent one. These are both are same only. Yes, and the fifth vector, that is the unit vector. A cap is also written as A bar by mod A. Null vector. The null vector means what? A bar is opposite to the B bar. And same in a magnitude, when we are take a sum, that is become null, 0 bar. Got it? Please note down. Any doubts? All the students once take it. Tomorrow we'll go with our remaining exercise part. Okay, now yes, and that is why in a synopsis, any doubt is there? Please raise your hand, and we have the more time for 5 minutes. Okay, now yes, please. Anyone have any doubts? Please ask me. Please raise your hand. Remaining, you are note down it. Anyone have any doubts from any branch? Alwal branch, you have any doubts? Yes, next. Jogipet branch, Ayappa Society, Bolakpur branch. If you have any doubts. Kapra branch. Suraram branch. You have any doubts? These are the fundamentals of vectors. Vani Black. Malapur branch. Kushaigula branch. Siddipet branch. Lotkunta branch. You have any doubts? Yeah, all the students, please write. There is a fourth and fifth definitions. Okay, just I'm given a pictures here. You write the definitions also. Okay. Yeah, this is only today's class, students. Tomorrow I'll go with the remaining practice sheet questions. Yes, and I hope you understood about these things. There is a whatever 19 components are there, especially that first 17, whatever there, that will be very, very important. The types of vectors are very important for the solving the problems of the this vector analysis, especially concentrate on unit vector, finding the unit vector and the Cartesian coordinates. Okay, and the modulus, how to find out the modulus and how to write the component of individual axes. Like that, today we are discussing a one-dimensional vector, two-dimensional vector, three-dimensional vector. Like that, they may ask, what is the two-dimensional vector of the given three-dimensional? Yes, along a XY plane. Like that, the question may ask for you. That's why please be concentrated on that components. Okay, thank you.